Hi, I'm Avery Fiore, the SAS VEX captain at the time this video is being recorded, and in this video I'll be explaining some things to consider when CADing a flywheel for this year's game Spin Up. I'll be making a sketch so I can explain some things more clearly, but do not simply copy my sketch, change things based on what your team's design is. Okay, and so we're going to get into it. Well, note that there is also not only one way to do this whole process. I just simply personally find it's easiest for people to learn when learning to CAD, plan things out in Sketch before actually CADing it. Right, so we're gonna, in this video, we're gonna create a top profile because the way I think about this is no matter what angle your flywheel is at, we're just gonna, create it as if it's flat. And then when it's imported into the master file, you rotate it there. Okay, and we're going to draw this from the top perspective. Okay, now what do we have? We have a disk, which is represented by this circle, right? And, according to GameOut, this is 140 millimeter diameter. Now I'm typing mm to, override the units being used, so it's not in inches. Okay, you want your default units to be in inches, though, because apart from the dimension for this diameter of this disk. Everything else in VEX CAD is, going to be in inches because we're using VEX pieces, and this is an American competition. So there you have it, right? Then we're going to talk about different wheel options. Given the nature of this disk, since it's very hard, okay, while it's made out of foam, it's not that soft. You have basically two options. Either you have very little compression, okay, and use a solid wheel, some kind of traction wheel. Okay, and what that would look like, let's say this is 4 inches. Compression might be like that amount, okay, that tiny intersection here. Not ideal, because then it's only in contact with the flywheel for how long, right? Or you can use a flex wheel. Okay, and a flex wheel, between a flex wheel and its disk, the flex wheel will give first. So that's good, and so you can have it compress into the disk a lot more. Right? So now we're going to add in some things. Let's say we're doing a double flywheel. I'm drawing another circle here. I'm going to equal these two together, because let's say I decide later I want to make this 3-inch diameter flywheel. Well, then that's an easy change. Next thing I'm going to do, I'm going to create a sketch line. Now, a sketch line is used when you're not actually representing something. You're just using it for dimensions. Okay, I'm going to do a sketch line from here to here. Right, then I'm going to put this on the midpoint there. Okay, and I can then dimension from here to here. Actually, it doesn't matter too much. I could just dimension the entire line and dictate how far spaced apart these two wheels are. Now, on second thoughts, actually, this isn't necessarily a sketch line. This could be a solid line because this could represent a C channel behind these two flywheels. Okay, and so it could say, and if it is represent a C channel, it has to be a multiple 0.5 inches so the holes line up. I could say this is, let's try 9 inches. No, I was wrong. 8 inches. Cool, we can see some overlap here. Right, that's nice. That's what we want. Now, in the event that instead you are using a single flywheel, what you do is you change this to a wall. Do that. Okay, coincident this to that point. And then in this case, you would want to tangent this side of the circle to the wall. Okay, and that means I have to delete that constraint. Right, if you ever get that error, that means something's over constrained and you need to probably edit it. So I'm going to tangent the circle to this line, and coincident center of this circle to this line. And I'm also going to make this line straight. Okay, there we go. 6 inches, and that's probably too much. I don't know, it's up to you, right? Maybe that looks like too much compression, maybe it doesn't. But let's say it's 6.5, that looks more comfortable. Okay, and that's like, you know, kind of a basic version of a sketch you're trying to plan out. Okay, and this you want to be sort of a 0.5 inch increment. Oh, I'm going to show you something. So it's not entirely the case if you're using a wall because of the specific interaction. Now I'm going to finish the sketch. Okay, I'm also going to show this quickly, so I'm not going to necessarily, you know, use the best CAD practices. You would want to, you know, create your structure component and all of that good stuff, which I'll cover in the end of the video. But right now I just want to show you this. Right, let's say this is the C channel behind at the bottom here. Just gonna, yeah. Okay, and then I'm gonna take another C channel. Right, and let's say this represents the wall. There, cool. So, yeah, let's say it's that, right? Right now we're drawing a dimension from this wall to one of these holes in the center line. Right, now if I actually take a measurement from this surface, this plane, to this hole, we'll find it's like 0.45 inches. And why is that? Because this surface is not lining up perfectly on top of this dot here. Okay, there's actually a gap. So, clarify, I'll hide these two now. If you're editing the sketch, right, you're doing a single flywheel with a wall, you want to subtract 0.05 inches for that reason. Okay, and that'll give you a more accurate dimension between the wall and your wheel. Okay, so it could be something like that. So you create that sketch, then you actually start putting in components. Okay, now we're going to talk about how you structure the file. I'm going to delete these two C channels. Okay, this kind of component, you're going to have structure, and then that would be like, you know, including the wall if you're doing a single flywheel, or just be like basically that back bar and maybe the ramp, a double flywheel. And you have your gearbox. Okay, now the gearbox is going to be interesting. For a flywheel, you definitely need a gearbox, unlike some of the other mechanisms. You need to create some kind of ratio that's going to make it spin fast. I'm going to show an example of 1 to 15 gear ratio, but that's not necessarily the best ratio. In fact, I'd probably say it's more like 1 to 25. Not that I absolutely know. You have to go figure it out and just test. But I'm intentionally going to probably CAD what I think is not the most optimal gearbox, so you have to go figure it out. Right. But what it would kind of look like is, let's say that's one C channel there, different C channel here. Right. If we're doing a 1 to 15 gear ratio, then that means one stage, we need to build a two-stage gearbox with one stage being 1 to 3 and another stage being 1 to 5. You might wonder which order do the gears go in. It actually matters a bit. So if I were to do the incorrect thing, which is put a 12 tooth there, and like a 60 tooth there, and a 12 tooth there, and then a 36 tooth there, would stick over math moments. Yeah, it would. Okay, this is going to create some problems. Now we have two C channels because we want every single axle to be fully supported. So this axle's fine. This axle's fine. Right. Now this axle has a problem. It runs into the 60 tooth gear, but not through the center of it. Okay, and that's not physically possible. So what you would then have to do is, like, you know, make this axle only go that far, and that's not good because now you have an axle that's not supported on both sides. Okay, and that's bad. Mechanical practice. If you want to know why, you can ask me in the lab. Okay, so instead, you want to order it the other way around. this becomes the 36. Okay, top one becomes the 60. So then you get around this axle issue. Right, something like this. And we can probably move this closer. C channel. Things I am not drawing in this sketch. Okay, you want spacers in between. You never want your gears rubbing up against this channel directly. Also think about it, right? With all this, okay, I actually drew it in not the most intuitive way, right? Your wheel would be here, okay, because this is the driver gear, this is the driven gear, this is the driver gear, this is the driven gear in a 1:15 gear ratio. And your motor would be there, right? Now looking at this, right, you don't want your wheel hitting other axles. These axles on this side should be pretty short, right? And you need to put enough spacers on the axle over here so that your wheel, you know, pops down enough. Right? You also want spacers everywhere. You also want shaft collars in key places to make sure the axle does not, you know, fall out any direction. And generally, that's, you know, best by putting the best location is put a shaft collar in between these two C channels, right? The other thing is you want to put standoffs between two sides because right now, right, this is only being held together by 3 axles and maybe some shaft collars. That's not very secure. You want to put standoffs between these pieces. And standoffs come in weird increments. So we have 0.5-inch standoffs and any multiple of that, effectively speaking. We also have 0.75-inch length standoffs. You can combine different standoffs together. So that kind of means we can create almost any length except 0.25 inches, but that's, you know, going to be too short and not relevant for this anyways. That's just given what we have in the lab currently. That, you know, that might be subject to change. But, you know, a way to think about this is, let's say you want to make a standoff length that is 1.25 inches. Then you can combine a 0.75-inch standoff and a 0.5-inch standoff. Okay, standoff piece is also found in the folder that says standoffs, right? And I believe it's at the bottom here. You would import this, okay? And you want to make sure the dimension between this C channel and this C channel is, you know, usable by a standoff. Okay, I believe that kind of sums up everything you need to consider for a flywheel. Well, okay, the one additional thing I'll add, right, I'll go back to this sketch. Oh, it's a side profile. No, it's top profile. Well, from the side, right, you just have to think about the ramp. Okay, how is this feeding into your flywheel? And that good stuff. Yeah, so that'll be it for flywheels.